So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here I have my Kali machine, and before I run BetterCap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor, and I'm going to write a very, very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes, but for now, we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket, and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS hijack plugin. So as I showed you before, this was in user, local, share, better cap, caplets, HSTS hijack. Make sure you use the one that I included in the resources, not the one that comes built in with better cap, because the built-in one will not work as you want it. So in here we have the HSTS hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. We added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say /root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run better cap using the exact same command that we've been using. So we're just giving it the interface as eth0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS hijack plugin. And as you know, all we have to do is just type HS and tab. This will autocomplete. I'm going to hit enter, and everything is running with no errors at all. So everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target, and as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS, such as stackoverflow.com. perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.com, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical. And if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HSTS if the target searches for that website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS, and because the browser is establishing a HTTPS connection, the data will be encrypted, and therefore we won't be able to inject anything in it. In the previous lectures, we learned how to use BetterCap to do a number of cool things. But everything we did it through a text or a terminal interface. There is also a web interface or a graphical interface for BetterCap that we can use to do everything that I showed you so far. The reason why I started with the text interface, because first of all, I actually prefer using it, and I use that instead of the graphical interface all the time. I think it's faster. You can use it to achieve your goal and launch the attacks much faster. It also requires less resources and less modules. Therefore, it's less likely to fail and it's less buggy. Not only that, but by learning how to use the text interface, I also showed you how to manually modify the caplets and the scripts, where they are stored, and how to use them properly without the need for an extra plugin, which is the plugin that runs the web interface. With that being said, some people still think the web interface is more user-friendly, and that's why I'm going to cover it in this lecture. So I'm going to start BetterCap by typing BetterCap, and I'm going to do -iface to select my interface, which is ETH0, and I'm not going to specify a caplet this time because I simply just want to start BetterCap on the interface that is connected to the target network. So we're going to hit enter, and that will run with no issues as usual. Now, if you're using the custom Kali image that I made for this course, then you can simply start the web interface by typing http-ui. But if you're using the original version of Kali, or if you're using BetterCap on a different distribution, then you're going to have to install the web interface. So you're going to have to do ui.update to install it, and then once it's installed, you can simply do http-ui. Now, like I said, because I am using the latest custom Kali that is made for this course, I can simply run it by typing http-ui without having to install anything. And if I hit enter, you'll see that it's going to run with no issues on this URL. So I'm going to copy this, and we're going to go and open it in my web browser. And perfect, as you can see, we get the login page for the web interface. So the default username is user and the default password is pass. I'm going to click on login to log in. And as you can see, we have a very simple and easy to use interface. There is no more commands that we have to run, even though we can run commands here through the command line. Right here we have the event log. So this is similar to what you see in here in the terminal, but it's in a much nicer interface. You can use the search bar here to filter if you're looking for a specific log or for a specific event. And you can actually click any event type to mute it, so you won't see any of that event on screen. All of this is happening in here in the events menu. The next useful page would be the LAN page right here, which will show you all the devices connected to the network. So this is similar to when we used to do net.show. As you can see right now we only have the router, which is at 10.0.2.1, and my current computer, which is 10.0.2.15. This is Kali. Now, as you know before, we had to start the net.recon and net.probe to discover all of the devices on the same network. So in here, instead of writing the commands, all you have to do is click on this play button to start the net.probe and click on this play button to start the net.recon. You'll get nice notifications in here, and as you can see, we managed to discover all of the connected devices. You can also see in here we have a nice tag to tell us that this is the gateway, and a nice tag telling us that this is our computer. And the devices that we discovered are these two devices, and you can see this is my MS Edge device, the Windows machine that we have always been targeting. Again, because this is a very simple web interface, you won't have to type anything. You can click on this little arrow right here beside the machine, beside the IP. You can either scan this machine for ports or add it to your spoofing targets. So you won't have to set arpspoof.targets to this IP. All you have to do is literally click here and it's automatically added to the ARP spoof. Not only that, but we'll see a nice little window in here to configure our ARP spoofer. And remember, we used to set this option to true, the full duplex. So all I have to do now is just click here to check it. And to start the spoofer, all I have to do is click on Start Spoofing, and done. Now we should be spoofing the target. As you can see, we also see a nice icon in here beside this IP to tell us that at the moment we are spoofing this IP, telling it that we are the gateway. So now if I go to my target and just do ARPA, you can see that the router's MAC address has changed to the MAC address of the Kali machine, which is this one. So that means that we are properly spoofing this device, telling it that we are the router, and we managed to become the man in the middle. Now, I've actually showed you how to do all of this before in details, so if you don't remember any of this, or if any of this feels strange, then please go back and revise the lectures where I covered these things. Now, I also showed you how to bypass HTTPS and partially bypass HSTS using a caplet. Again, we have a nice menu here for caplets. And as you can see, we have all of the caplets currently available with BetterCap. And all you have to do is just click on the caplet that you want to run. And in my case, it's the HSTS hijack caplet. Also, if you remember, when we were modifying this caplet, we used to have to open the location where the caplets are installed, and then open the caplet in a text editor, and then modify its options. Whereas in here, you can literally modify any options you want within this menu. Click on the disk icon right here to save, and then click on play to run this caplet. And as you can see, you get nice notifications telling you that everything got executed as expected. And right now, we can go ahead and test this. So if I go here and just clear the browsing data as usual, and then if I just go to a normal HTTPS page, such as stackoverflow.com, you'll see that this will load over HTTP. So we can log in and we should be able to get the username and password as I showed you before. And we can test the partial HSTS bypass. So if I go to google.ie and search for Facebook, click on the first result, and perfect, as you can see, it's loading over normal HTTP here again. So if I log in, the information will be captured by my sniffer. So as you can see, it is very, very easy to edit couplets and even run them through this web interface. You can also run all of the other plugins through the advanced menu in here. So for example, if you wanted to start the sniffer, all you have to do is just scroll down here looking for the sniffer. And we have it right here, net.sniff. If I click on that, as you can see on top, it's not running. And right here, instead of running the commands, all you have to do is just click on the command that you want to run. Not only that, but if you wanted to modify any of the options, again, all you have to do is just type whatever you want to modify in here, click on the save in here, and then run the command that you want to run. So if I wanted to start the sniffer now, all I have to do is just click on net.sniff on, and this will start the sniffer for me. Now, the sniffer combined with the nice events that we can get in here makes it easier to filter through the data that we capture, but it's still not the best way to filter through the captured data. I will cover how to properly sniff data and filter it using Wireshark, which is the best tool for sniffing and filtering data. But again, this web interface right here provides a nicer way of interacting and using better CAP. Now, I didn't show you how to use the Wi-Fi, the BLE, the HID, and the Poison menus because we actually did not use any of these modules previously. So I just wanted to focus on showing you how to do everything we've done so far using this interface. Like I said, it is easier to use, I agree, but once you get used to the terminal interface, it will be just as easy as this one. To me, it's more organized. It can be used to achieve my goals much quicker. It uses less resources and it's faster. That's why I prefer using it over the web interface. And if it wasn't for showing you how to use the web interface, I wouldn't even install it. But at the end of the day, I wanted to show you both options, and obviously you're free to use whatever is easier for you. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers, and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allows you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool, and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now, and it's going to become more clear to you. So I'm just going to go to Kali, and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that, and that's going to load the program for me. This is just a normal error, just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open. And in here, it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodome, or using Man in the Middle F, or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now, what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here, and you'll see that ETH0 will not be affected, and the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this, it's still constant, and we can only capture packets that go through ETH0. So now you'll probably ask, then why Wireshark is so useful? Why are we even talking about it if we can only see things that go to our own computer? Why are we talking about it? Well, we're talking about it because we see there is a large number of ways that you can become the man in the middle. We learned how to do ARP spoofing, and in future lectures, I'm going to show you how to do it by creating a fake access point. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So for now, I'm going to become the man in the middle using ARP spoofing. You can use ARP spoof or bettercap as I showed you earlier, but I'm going to use bettercap using the exact same command that we used to do. So we're literally just doing bettercap, followed by the interface that is connected to my target network, which is ETH0, and I'm launching my caplet, the spoof caplet, so that it configures the ARP spoof module and runs it for me to put me in the middle of the connection. So I'm going to hit enter, and as you can see, it's working as expected. So right now, I should be in the middle of the connection, intercepting anything the target Windows machine sends or receives. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google it, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we've seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine. So in here you can select the interfaces that you want to start capturing on, and you can actually select more than one interface, and all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on to browse, and you can store the packets that you're going to sniff somewhere, and then you can analyze them whenever you have the time, at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just going to click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured, and it will be displayed in here. Anything. I mean images, pictures, messages, cookies, anything that that computer does on the internet will flow through ETH0, and therefore will be captured by Wireshark. So it's not like man in the middle left where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. Now, I want to go and generate some traffic on the target computer so we can analyze it here. But before I do that, I'm going to go back to BetterCap, and I want to start my HSTS caplet so I can downgrade HTTPS to HTTP, because if everything goes over HTTP, we won't be able to see or read anything because, like I said, everything will be encrypted. So I'm going to hit enter. This will work as expected. We'll go back to Wireshark, and let's go to the target computer. I'm going to go to google.ie, and let's search for something. So for example, let's search for Z security. And keep in mind, everything is loading over HTTP in here, so that's why we'll be able to read and analyze everything that we're loading right here. Now, let's go back to Wireshark and see how we can filter this information and discover the website's visit by the target, see the requests, and all that. So I'm going to click on the stop button to stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent, basically. You can also see the source. So this is the device that the packet was sent from, and you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.06. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see we have some black packets, and these are TCP packets that had a problem, that had issues. Now I know what you're thinking. There are so many packets in here, and a lot of them might not be useful to you, depending on what you're trying to get. But don't worry about this. In the next lecture, I'm going to show you how to filter these packets to only display the relevant ones, and then analyze them to extract the useful information. In this lecture, I want to spend more time with Wireshark, showing you how to filter all of these packets to only display the useful packets, how to trace them, what do they mean, and how to display more information about each one of these packets. Now, what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So this is the traffic that was basically sent by the browser, and is usually sent by web browsers. They always send traffic over HTTP or HTTPS, and since we're downgrading HTTPS to HTTP, you want to use the HTTP filter to see everything that a target person is doing on the browser, regardless of what they're doing, whether they're browsing websites, whether they're watching a video, whether they're looking at images, whatever they're looking, it will be loaded over HTTP. So, looking at the first record right here, we can see that this request is sent from this IP, which is the IP of my target, to an IP on the internet. So we can see that this is not a private IP, this is an IP on the internet. So it's sent to a server. And if we double click this record, we'll get much more information about the packet itself. So we have the information about the frame, which includes the size of the packet, it includes the interface that it was sent on, the time, and all that. In the Ethernet, we have information about the source MAC address and the destination MAC address. So where did this packet go from and where did it go to? Remember when I first spoke about packets and how they always travel from a source MAC to a destination MAC. So this information is all stored in here. In the Internet Protocol, we have information about the IPs. So in the internet, we had information about the MAC addresses. In the internet protocol, we have information about the source IP and the destination IP for this particular packet. In the transmission protocol, we have information about the port, so we can see that this went from this source port to port 80. This is usually the default port used on web servers. So in most cases, whenever data is sent to a website, it will always be sent to port 80. But the most important part in here is the hypertext transfer protocol, which is basically the data sent over HTTP. Clicking on this will give us information on whatever that has been sent over HTTP, and like I said, this would contain everything that was sent to and from a browser. So right here we can see that this particular packet sent a GET request to a website called google.ie. Now this is literally when we typed google.ie, we didn't search for anything, we didn't really do anything. You can also expand this to see more information about the actual request, and you can even see the HTTP header sent if you want to get more information about this particular request. Now this whole method of getting information follows with all types of packets, so you can double click any packet you have and you'll be able to read the data sent within this packet. Now you can also in here see an arrow, which basically means that this was a request, and the arrow back here marks that this was a response to this request right here. Now moving down, you can also see requests for images. What you can also do is click on any of these packets, for example, again, back to this GET request, right click it, and go to follow HTTP stream. And this will basically follow the stream that this request has caused all the way down to the response. So if I click it, you'll see the response for this particular request was this right here. You can see that this was a PNG, and literally the binary content of this PNG image is right here. So as you can see, we're literally getting the raw data in here. Now I'm going to close this and go back to what we had, which was HTTP. Now if we keep going down, you literally see everything that has been sent and received by the target. So for example, again in here, we can see this was a JavaScript file that was loaded by Google. Then in here, we can see another GET request, and this GET request was when we searched for Z security. So you can even see the search term in here. So let me double click this to show you in more details. Again, this automatically went to the hypertext protocol part. Like I said, this is the HTTP part, whatever that gets sent to the browser. And you can see that this was sent to google.com, first of all, and the URI, so whatever went after google.com, was search and what we
Psalm 111. Praise the Lord. I will praise the Lord with my whole heart, in the assembly of the upright and in the congregation. The works of the Lord are great, studied by all who have pleasure in them. His work is honorable and glorious, and his righteousness endures forever. He has made his wonderful works to be remembered. The Lord is gracious and full of compassion. He has given food to those who fear him. He will ever be mindful of his covenant. He has declared to his people the power of his works, in giving them the heritage of the nations. The works of his hands are verity and justice, and all his precepts are sure. They stand forever and ever, and are done in truth and uprightness. He has sent redemption to his people. He has commanded his covenant forever. Holy and awesome is his name. The fear of the Lord is the beginning of wisdom. A good understanding have all those who do his commandments. His praise endures forever.